Hello, everyone. Thank you so much for joining us today. Very happy to share with you what we've been working on with SRE practices, Stackdriver, and the Istio service mesh. My name is Jay Judkowitz. I'm one of the lead PMs in Stackdriver at Google. My co-presenter, Tim Kelton, is co-founder, head of SRE operations and security at Descartes Labs, a customer of us. And so we're going to learn a little bit about what we're doing in the product, and then see what Tim's doing over at Descartes. So the purpose of everything here is to help people adopt SRE practice and to have the same kind of efficiency operationally as we have at Google. And so we're not going to be able to do the presentation without starting with a quick overview of SRE. Then we're going to dive into Istio. Istio is a really important ingredient for tying together the SRE practice and the Stackdriver tool set, as we'll find. Tim will come up and talk about what Descartes found in real life, trying to manage their application at scale, and how these technologies are going to come together to help them. We'll talk about the Stackdriver integration with Istio specifically, and then we'll get into a demo. Who here was at the keynote this morning and saw Urs's demo? All right, so we're going to see that, but in more detail and on Tim's stuff instead of Google stuff. So, brief overview of SRE. Google has 8 products with over 1 billion users on them. We manage that with an SRE team of 2,500 people. So, not that it works this way, but that's over 400,000 users per operator, which is pretty crazy economy of scale and ability to get the most out of folks. Now, the challenge that the SREs have is, how do I keep everything super reliable? Of course, Google.com is kind of synonymous with, is my internet up? But at the same time, Google has this reputation for innovation, right? There's a zillion developers writing all these applications, doing experiments, pushing things out, pushing the envelope. How do you balance the need for availability and reliability and performance with the need for moving the business forward and innovation? That's what the SREs are about. So what have we found are the ingredients? Now this isn't an SRE talk. The SREs would do a full hour on this, so I apologize to anybody watching on YouTube later. This is going to be a very brief overview. And this is the observations we found from the Stackdriver tooling side. Like when we observe SREs, what do we see makes things special? First off is a culture. SREs aren't just running around with a pager trying to squash bugs and react to problems. It's a very proactive organization. They engineer the reliability into the products. So pretty much all the work they do, it's front-loaded way before you ever have an incident. They're automating processes for monitoring and automated remediation so that things hopefully don't get to a page. They're doing production readiness reviews with the application teams. Applications can't go into massive scale and have SRE take the pager unless they're engineered for reliability. They're setting the principles of monitoring and alerting. They're managing the customer promises, whether they're internal or external, the SLOs, which you'd think I'm going to talk about right now, but we're going to push that off a little bit later till we talk about the SLO feature, but that's like the most important thing. And of course, they do manage the incident response. When there is an incident, very scalable and flexible and predictable process called IMAG, which you can learn more about in the book. And they're responsible for the blameless post-mortem culture that we have, which is really important. You can't make things continuously better if people aren't comfortable saying what's gone on, saying what went wrong without fear, if they're afraid of retribution. So that's kind of a brief overview of the SRE culture. Now, for that culture to work, they need data. Everything the SREs do is data-driven. Right? Is it working well? Is it reliable? Is it cost-effective? Is it going to scale? Without the data, nothing works. So can you imagine? So the SREs, like I said, we've got great economy of scale on that team. They're outnumbered over 10 to 1 by the developers. Imagine the SREs went to every development team and said, I want you to put this metric and this metric and this metric and this metric and put it here, 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 and here. Short conversation, right? It's not going to go very well. So what we've done at Google is we've actually engineered the SRE practices into, from telemetry at the least, into the platform itself. So when a Google engineer on an application deploys application code, it's not just a container or a VM. It is a service. It's got a beginning and an end. It's identifiable, schedulable as a unit. It's got a discoverable API with a known contract. And it's got security and quota management already available to it. And it's got the telemetry, standardized telemetry, so that anything about that service is sent back to the monitoring systems. So this is pretty cool. So this allows SREs and the software engineers to actually be much more collaborative, because we're not pushing work on one another. We put the work on the platform, you deploy the code, everything works. Now, there's a little bit of oversimplification. I'm sure Google engineers will say it's not always that easy, but it's a pretty good approximation. So now what we've done is, well, you all can't all develop on Google, or you don't want to work at Google, but what we tried to do is we tried to externalize the concepts that we have into products in the open source. So our container scheduler, Borg, is available as Kubernetes, the concepts. We're going to talk about Istio. That is basically an external, inspired by one platform, our API management system. Our secure RPC system is externalized as gRPC. And our instrumentation, the things that actually send the metrics, traces, and whatnot, it's something called Census internally. We've externalized as Open Census. So not only have we tried to make this available for folks to use on Google, but because it's open source, we'll let you use it on competing clouds, let you use it on on-prem as well. So hybrid, multi-cloud version of this opinionated infrastructure that'll make it super easy for you to manage applications as a collection of services, rather than a bunch of infrastructure, willy-nilly. We're not going to talk about this much at all, but as you can imagine, with all those engineers writing all that code, sending all those standardized metrics, we got to put it somewhere. So we have systems inside Google that scale. We get petabytes of logs a day. We have billions of monitored resources, hundreds of billions of time series. And this same system is actually the basis. It's the bottom half of Stackdriver, the part of Stackdriver you don't see. So when you use Stackdriver, you're actually storing your metrics or traces with in the same kind of system that Google is storing their own. Lastly, what this presentation is really about is the tools. We want to have this culture change, deal with monitoring by SLO and working off of this standardized platform with these standardized signals. Well, to make that all happen, you have to have tools that bring it all together. There has to be great UI and workflows that let you see what you've got and be able to use it. And that's kind of the tip of the iceberg, right? You always see the iceberg, and the thing on top is what you see. So those first three columns, there's a lot of work in there, and we're going to describe the tip of the iceberg and show you the tools that we're building. So with that, we want to drill down on Istio. Just show of hands. Who here has heard of Istio before? Fantastic. I guess that's why you're in a room. Who here's used it before? Oh, wow, this is great. So I will do a brief treatment of Istio, because again, this is not an Istio talk, but I do encourage people to go to the Istio sessions as well. So when people have started breaking up monolithic applications into smaller and smaller microservice applications, the prototypical 2-pizza box team, you started creating a lot more communication between a lot more pieces of software. And that creates a lot of problems, right? If you had one monolithic piece of software, you'd put the security and the quota management and the instrumentation, you just put it into that monolith and be done with it. But now, if I've got tens or hundreds of microservices, I don't want to do that again and again and again and again. I just want to do that once and be done with it. And that's what Istio provides. It provides security for microservice communication, so that the security becomes configuration rather than baked into the code. It provides operational agility. So you could say, hey, I want to have this traffic splitting, 10% go here, 90% go here. I want to do the canary. I want to do the rollback. I want manage how the traffic flows. Again, that comes from Istio. And lastly, the uniform observability. Because Istio is in this place, this service mesh that's available to all services, the mesh itself collects the metrics and traces and sends everything to the monitoring system of choice. So this service mesh is what creates this open system for being able to deploy code as services and manage it through config rather than more and more software logic. In terms of the architecture, so the key thing here is the Envoy proxy. The Envoy proxy is what's sitting in between service and service, and it's what lets you. It's where the metrics for the API are captured and able to be sent off. The proxy is also able to call out to the mixer for things like quota checks and security checks. And the mixer then doubles also as an aggregation point. So instead of having to have a zillion streams coming back to your monitoring system, being able to batch those up and send it back in a sensible way. Lastly, you have Pilot that is pushing out the configuration everywhere so that we can have as many stateless pieces as possible. And Citadel, which is dealing with the identity and security pieces. So that is a brief overview of SRE, brief overview of Istio, very theoretical to this point. So let's see practically, how does Tim use this to make Descartes better?
Thanks, Jay. So just as Istio is focused on providing visibility into your services and what is happening between them and how they interact, Descartes Labs is actually focused on improving visibility and understanding of changes that happen every day all over the earth and all over the globe, and how those changes then might impact our customers, their businesses, and even their global supply chains. And we accomplish this through building of machine learning models, and those are fused together with many different types of geospatial and remote sensing data. And those, such as satellite imagery or aerial imagery, so you can kind of think of that almost as somewhat of a service level indicator of monitoring changes all over the earth. And we're a startup that's actually just a few years old. Our headquarters are up in Santa Fe, New Mexico, way high up in the mountains. And we don't actually have any data centers. We don't have any physical servers. So the cloud has been this critical component for us as far as infrastructure. We could have never built something on our own this quickly as just a couple-year-old startup. And we have nearly 15 petabytes of satellite imagery, and our machine learning team needs to scale models over tens of thousands of cores on any given day. So whenever possible, we really push to use managed services. We're heavy users of GKE. We also use Stackdriver for a lot of our monitoring, logging, tracing, all of those types of things. So how do we build these service level indicators for the whole Earth? Well, we do this by building machine learning models, like I said, and pulling together this imagery. But it's also not just about having a single source of data. Most of the time, the accuracy in our models comes about from combining geographic data across large geographies, often through many different spectrums of light, not just human visible, things like infrared, near IR. Sometimes we'll use remote sensing such as synthetic aperture radar or signals like that. And then it's also large temporal windows. It's not just hours or days, but sometimes we're actually spanning and building models and testing them back over decades. And no one data set usually will just be the answer. So in some ways, this really isn't that different than understanding what's going on with your microservice. It's often the fusion of data from many different services, many different sources together that give you a full picture of how the application is actually interacting. And so Descartes Labs models pull together internal data. We pull in public data. So you could lots of imagery from NASA or Landsat, also the European Space Agency. But we also pull in many commercial data sets. We have a lot of our own data. But we try and pair the data with what will provide the biggest answers to provide context. And our goal is to scale up building of models over massive geographic regions, over many different modalities, and over really large temporal windows to provide that insight for our customers. Some examples would be just last Friday, we were running models and looking at building looking at hurricanes and Florida and things like that. We were able to quickly scale out and build models and identify every single building in the whole state of Florida in just a few hours. So what does kind of our architecture look like? Well, we're very GKE-centric on our microservices. We have around 50 microservices. We have, as I said, around 15 petabytes of Earth observation and sensor data. Most of that is actually stored in GCS. We have some core key services that can selectively pull just parts of the objects from GCS. It could just pull, for example, a single band of light and just be able to query that. And we have to be able to scale those compute jobs individually to tens of thousands of cores. Excuse me. And our microservices, we use a wide range of data persistence tools besides just the object store that's on GCS. We can pair the microservice with the appropriate backend. It could be Cloud SQL or Bigtable or any of those databases, and we leverage a lot of them for each service. But all of our monitoring, logging, and tracing is then back into Stackdriver. So what are some of the challenges we face with scaling microservices? Probably like everyone here who's had a lot of different services, one of the biggest things is visibility. Visibility, understanding of the source code, the components, what was deployed with each of the microservices, how each of those microservices then start to interact together. How many times does a black box tester maybe use one intended use case, but then this microservice is really valuable and somebody else finds out about it, another developer starts using it in a totally different way that you never intended. And so when my application changes, another problem, how do I quickly observe what's going on? We'll have applications that are configured with a variable maybe was changed downstream, and there was a huge consequence. It didn't show up in early tests. Maybe it changed the traffic. Maybe the service-to-service interaction is now different. So if I release a new version of code, how do I gain understanding about, like, did this improve my efficiency on the back end of the service? So what's really needed? Prior to ever writing a service level agreement for any of our customers, we really have to kind of understand the performance baselines and the behaviors of the actual application and how it's performing in real world with real load traffic. So what matters or is noticeable, what matters or is notable, it might not make any difference to the customer. You know, we might have built metrics and dashboards, but the end customer actually can't see the difference. It could have problems still. How do all the components of the service then work together? How can I easily track how many errors are acceptable for our customers? When do we need to take a step back on our development roadmap and look at, instead of maybe building new features, we need to improve the core stability? What does the product manager have to figure out those types of priorities? So overall, in some ways, then when we move to Istio, this really isn't super different. And this is kind of awesome. You know, I am not putting instrumentation libraries into every single microservice that we have out there. There is that approach, and I could do that, but we have services written in a number of different languages, and I'm guessing many of you do as well. And so with Istio, as Jay mentioned earlier, one of the keys is the Envoy proxy, and we inject the sidecar proxy in with the microservice, and that gets deployed, and you can actually set that up to happen automatically. So when those pods get deployed, the Envoy sidecar proxy gets reported in, and then that metric starts going into the back end. So this starts to give us instant visibility into each service, which services are calling that specific service. It gives us service-to-service authorization. We can do things like we might need to rate limit a service. For example, I like to use auth as a really good example. It's okay if it gets hit 5 times a second from one pod to another pod. But if it starts getting hit 20, 30, 40,000 times a second from a pod, there's probably something fishy that was going on in that code, and I would want to go check that. And overall, we have now all of our services are talking back into the backend Istio control plane with the pilot and the mixer, as Jay was mentioning. And then we have Envoy just injected into each of those containers. And so with that,
thanks so much. So, all right, so we're going to talk a little bit about the product that we built, like what we've done to Stackdriver to be able to better monitor Istio with all of that data we had. I won't go into gory detail because we're just going to show you with Tim. Next, he's going to come up and show you what Descartes looks like. But there's 3 problems we really wanted to solve. First problem is, what the heck am I running? What is my service architecture? I can look at it from a code perspective, right? I can look at GitHub and see all the different source files, and you know, maybe look at a build system and see what the artifacts are. But that doesn't tell me anything about the infrastructure. I can look at the infrastructure and look at VMs and pods and containers, and that tells me what I'm consuming, but it doesn't tell me what I'm running. What I really want is, you know, how many of you have had to train a new hire? What's the first thing you do? You go to the whiteboard, right? You go to the whiteboard and you draw a picture. You say, all right, we have this thing here, which does this function and talks to that thing there, which talks to that function, which depends on this thing over here. And it turns out humans have an incredibly intuitive understanding of what makes up a complex system. And what we wanted to do was be able to make it so you didn't have to draw that on the whiteboard, but instead got that automatically. And that's what the service graph is about. So we're able to, you know, if we had to build this up from random pods and containers, not so easy. But because Istio is opinionated about where a service starts and ends, and it's able to track which services are talking to which other services, it's actually, I'm not going to say easy, but it's certainly a lot simpler to build this graph. And that's what we've done, is basically graphed out the entire Istio service topology. Now, we've done a couple other things here that are important. One is we've added a time element. So how many of you have ever had to do tech support for somebody you love or care about? All right, what's your first question? What did you change? And what is their first answer? Nothing. And are they ever telling the truth? No. So on the bottom there is a time slider. And so that time slider lets you go back in time. And so you can go see, okay, what did the service look like an hour ago? What did it look like 2 hours ago? See where the changes come in. Also, this doesn't replace all of your dashboards and everything, but you have basic metrics for each service. I mean, what are the golden signals? What do people care about? What is my traffic? What are my error rates? What are my latencies at various percentiles? You get that at a glance. And that's really, really important, because let's say you get a support call about something at the top of the tree. Do you want to go debugging that thing right away? Maybe. But maybe not. Maybe it's actually the thing it depends on has problems. So if you say high latency on something up top, and then you look at its 5 dependencies, and you go, oh, wow, one of those 5 actually has high latency down at the bottom. I bet the high latency at the top is caused by this one thing down lower. Then you can go debugging right at the source of the problem. So this is an excellent triage tool, because it gives you an at-a-glance view of all this stuff. And then lastly, it lets you drill down. It doesn't end at just a service list. It actually, you can double click on these and go down from the workload level to the deployment, to the replica set, to the pod, to the container, and actually see if it is an infrastructure problem, which pieces of infrastructure you're going to want to look at. Problem number 2, how is my service behaving? Well, again, you can look at it. There's a lot of different fractured points of views of this. You could look at dashboards, which show you a lot of different metrics about the infrastructure or response rates or something like that, and that'll give you one idea. Or you could dive deep, deep, deep into the code itself and go, okay, what does the distributed trace look like? How is my latency distributed between different microservices that make up the app? But again, you're not getting a big picture view of it. Like, where do you start with? How do you build your conceptual model? And this is where we're actually going off to the, I promised I'd defer the SLO conversation to here. What you really want, or at least what we want at Google, is service level objectives for each service. So think about how many servers and how many containers are running at Google. Imagine if every time a CPU went hot, an SRE got paged. That would never work, right? That would never scale. No 400,000 users per SRE at that model. So they automate a lot, right? They automate the auto scaling. So okay, the CPUs go hot, you auto scale, CPUs go down, everything's fine, nobody gets paged. But you can only automate so much. You automate first thing and the next thing and the next thing and the next thing, and at some point you get to something that didn't get automated away and the customer experiences pain. That's what we want to measure. We want to learn, when does the customer have pain, alert on that, and do something. So the first question is, what is a service level indicator? What is the thing the customer notices and cares about? There could be 100 answers to that question, but there's 2 that come up again and again. One, particularly for API-based services, one is availability. What percentage of my responses come back with 200s? The second thing, latency, performance, right? Let's say a customer needs 300 milliseconds response time on an API. Okay, what percentage of API calls come back with 300 milliseconds or less? Those are your service level indicators. A service level objective is when you put a target on that. When you say, I want 99% 200 responses a week, or I want 99.5% 300 milliseconds or less response time. These service level objectives are now the promises that we're making to ourselves about our service. It may be communicated externally, it's often not. Now, but it's important, because without those objectives, it's really hard to figure out whether you're doing well or not. Now you notice, I didn't say 100%, right? If I wanted 100% reliability, we'd never release anything. So when you take 100% minus the target, that's your error budget. Your error budget says, how much slack do I have this period? So if your error budget is really super high, you're not spending it. What happens when your boss gives you money budget and you don't spend it by the end of the year? Do you get that money again the next year? No, they take it away. So budget is there to be spent. And so if your error budget is super high all the time, well, maybe it's time to release more code. Maybe it's time to do more experiments. Maybe it's time to see if you can get more features out to your customers, because if it's more reliable than your customers need, they'd prefer features. What if the error budget is really, really low? Well, you may want to hold off on that big release, right? And what if your error budget is still within limits, but dropping precipitously? Wake somebody up. Right? Because otherwise you're going to be below and you're not going to be happy. So the error budget is really how the SREs live and die, and how they organize their lives, and how they know what they should and shouldn't do. You have a contract with your internal or external consumers. You measure it, and you work based on what those measurements show. And then of course you can get get a report at the end. You can say, okay, did I meet this SLO for this period? Now, these SLOs are pictures from Stackdriver. So one of the features that we've got, so the first feature was the service graph that we showed you. Second feature is this SLO feature. So both for App Engine, which isn't really a part of this talk, and Istio, we're letting you we're making it super easy to put service level objectives on your services, measure them, and get the graphs automatically, and then be able to set alerts and know when to page people based on those SLOs. Problem number 3, debugging. So who here's used Stackdriver before? All right. How many, I mean, if it's a small room, I'd ask how many parts you can name. There's metrics and logging and traces and profiler and debugger and dashboards and error logging, and I'm probably skipping a couple. It's a pretty broad product. And they each have their own screen, right? So I can go to a metric screen, I can go to a log screen, I can go to a trace screen. But if I'm debugging a problem in a particular service, I just want to know everything about that service. Don't show me all the other stuff. Show me everything I care about this service in one place, scoped to the time of the problem. And that's what we've built with the service dashboard. So the service dashboard has a number of elements, which you're going to see in Tim's demo in a second. It's got a timeline slider up above, which shows all of the relevant events. You can open and close the time slider to get to the around the events you care about and around the time you care about, and that filters everything else that we're going to talk about. There's events on the side that give you more details about what's been going on, and then there's these tabs. And so the first tab is SLO tab. Pretty important because we're starting from when you're debugging, you always start from the broad and go deep, right? So the broad thing is, my SLO is error budget's dropping. Okay, that's the broadest. All right, what's the next level of depth? Metrics. So for any given service, we could say, all right, here's what the response rate is, the transaction rate is. Here's what the latency distributions are. And then we let you slice and dice that. So oftentimes a service doesn't just flat out die, right? What usually happens with a service is some subset of the traffic is broken. This version, from this sender, in this location, right? You want to be able to slice and dice the traffic and figure out who's the outlier, right? Who's the subset of traffic that's making the overall thing bad? And so the metrics, the service level metrics about availability and latency let you do that. Now, once you've figured out what subset of traffic you care about, you can dig into diagnostics, right? Let's look at traces. Let's see what the different percentiles of traces are. Let's go into that. Maybe it's not a performance. Maybe it's an availability thing. So we want to look at error reports and see, what kind of stack traces we've got. And then there's everybody's favorite, the least common denominator of debugging, logs. When all else fails, read the log files. So with this, we're able to go, again, from the big picture of the service graph, saying, hey, which service is likely at fault, down into that service's dashboard, find the SLO, to the service metrics, down to the individual diagnostic pieces. Ultimately, we'll also want to include debugger and profiler and have launch off into there, but you can imagine how that would add on later. So, who wants to see Tim show you the product instead of me talking and doing screenshots? Yeah, all right. So please switch computers. Thanks.
All right, so I am coming in. I'm brand new. I'm a new SRE. Like Jay said, we could whiteboard this all out. But now my services are actually injected with the Envoy sidecar proxy. They're all reporting up into the Istio control plane. And I can start going in and exploring, what does my service actually look like? I can start trying to understand, are any other services calling our service? So like I said earlier, we serve lots and lots of pixels or imagery. It's also known as rasters. So we have a service called raster. And this service, just as a background, this is a Python Flask application that's hitting GCS on the back end. And I can see, actually, it looks like I have two types of traffic. I have data going to the metadata service, and then it looks like I have a client requester from Blackbox. So I actually didn't know. No one told me in the documentation anything about this metadata service. I'm just trying to learn. So I'm going to actually go look up, what is the metadata? Well, in our case, metadata is information about each scene, which bands of light, which time was this image taken, maybe which sensor was it from NASA or something. That would be the types of information that we would store in metadata. And in this example, we have the back end of metadata, we've made an index to be able to look things up. And as Jay mentioned, you can start to see high level. I can see some requests counts. I can actually also see here, I don't see any traffic here, but oh, this is non-200 responses. So that's actually good that I'm not seeing anything. And I can also see response latencies and dive down into, what are my long tail events there. But this is just a high level overview. Then one thing to point out, because this is just an off-the-shelf, or not off-the-shelf, open source Elasticsearch server. So that's open source code that I'm not adding any sort of libraries or metrics to. Instead, I'm just sitting behind the Envoy proxy. So now I know that we've made our SRE team wants to throw requested traffic that we know about. So we made this black box tester. And that actually uses our Python client, and it calls out to these services. It looks like it's now calling to metadata and raster. I can see that from the traffic side. And so that's the use case that I've seen at this given time. So now I'm going to go look at an SLO that I've made. This was over a week, and I'm looking at the SLO for our raster service, or I'm sorry, this is over the last day, and I'm looking at all the tail events. I can start to see that, oh, it's actually hovering right around that service level indicator line, that threshold that we set. It's 99.5% of that indicator. And now I'm looking at the error budget. It looks like we were actually really good and until late last night, and then it looks like latency started just dropping off, and our error budget is actually starting to go down. And actually, I'm starting to see now that it looks like it's actually declining more. I can also dive into some of the events that happened earlier today. It looks like there was an event around just before noon. I can see that we had some incidents. But now I want to actually zoom in and say, actually, what's going on right now? And it looks like my service has actually dropped quite a bit below, and I actually have a big problem right now. I need to figure out what's going on, and I need to basically stop the bleeding to some extent. I'm seeing latencies dropping well below what we were hoping for. I'm seeing we're burning error budget. I'm seeing our service is out of compliance. Basically, it's kind of all hands on deck at this point. So what I'm going to do on the back end, I've seen that raster is where all those core requests are coming in. So I actually am going to, probably we didn't set our HPAs correctly. Maybe we're not scaling on the right metrics. Maybe we need something more specific. But I'm going to scale this up and just try and get the service back in compliance. And so while these pods are all initializing, I'm making a whole bunch right now. While these pods are initializing, as was mentioned earlier, I can start diving deeper into the problem. I want to get a better understanding of what are actually the metrics that we're seeing. And so one thing I can do is I can actually, because I know which service is talking to which other, Istio knows, sorry, I don't actually know at this point, but I can actually group by something like the source workload name. Another thing I could do is I could actually look at response code. I could say, just show me the 200s, for example, if I knew all my traffic. But I actually know there's a problem. So I want to see, are all the workloads hitting this API the things that I know about, or is there actually something new coming in? And then I can scroll down, and I can actually see that there's a new service that's hitting. Some developer got the wild idea that he knew how to use my API, and he was going to make this killer app. And he is basically crushing that single pod, so that was never going to scale. And my latencies were going to basically drop off. And I can start seeing here that the latencies are getting slower and slower. So hopefully now I've added more back-end raster pods. I should be able to start handling that load. And now I might want to go in and dive even deeper. The next step I would do is I would actually want to look at the diagnostics themselves. So these are some of the requests and the percentile and the latency, and I can actually see a sampling of what some of those calls to raster were. I can actually start going in and seeing, here's this raster service, and I'm seeing these slower times. These were in the 90 and 95th percentile, and I can actually start seeing the full traces. One thing to mention, I can click around on a few of those, and that starts, we've actually implemented, I can look down at that time window, and I can actually see some of the logs coming in, and I can look at, we were having some problems, it looks like. I can see logs relative to this small time window just to this service. It's already kind of filtered that down for me. I didn't actually build any of these dashboards or widgets. So that's really helpful. Here I actually see some good requests. I can actually see we served raster imagery. It looks like this was a metadata request to a NASA Landsat scene. So that's really nice to be able to compartmentalize that. Oh, and look, I just now am seeing an incident pop up. I'm seeing I actually have an error budget. I'm losing error budget, and I now have a new incident. So I might want to start understanding that. So now at this point, hopefully we've stopped the bleeding. So at this point, I thought it would be helpful to just show actually how I make a SLO to begin with. Since all of my services are behind Istio, I can actually use the service graph or the service explorer, and I can actually see all of those services themselves. And so I can actually go find the I can actually go find which service was this? Okay, I am in the Roswell Kubernetes project. I'm picking good New Mexican names. That's a city in New Mexico if you're not familiar. And I can go look for, let's see, where is Roswell? So, sorry. Oh, I'm already selected that. I've self-selected, but these are were all populated from Istio. So now that I've populated that raster service, I can actually add an SLO. And I can do an SLO with two different types of service level indicators. One would be availability. Maybe my application always has to be up. Like that's what's most critical for our line of business. In this case, I kind of just showed you we're serving all these varying size imagery, and really what crushes us from day to day maybe is latency and how quickly or how responsive that service actually is. So in this case, what I'm going to do is I'm going to make this service respond with 4,000 milliseconds or 4 seconds. And then I can pick a period. In real life, I would usually often use maybe a month or at least a week. In this case, we're building a demo, and I'm showing you just walking through how we build these. So I'm going to actually select just one day. And then finally, I can pick a target compliance. What's the percentage of traffic that should be served? What do we deem when the latency falls off falls lower than this amount? It starts being a really bad experience for our customers, and we kind of want to do something about it. So in this case, I think I'm going to try 99.5% of that latency. So remember, this was just over a day, so 99% of that traffic, that's, if I broke 99% up in minutes, that's about 7.5 minutes of the day that the latency can't be below. So that's actually probably pretty high. It might be too aggressive. I'm not sure. I'm going to actually see. Now this is really nice because what's happened is they've looked at the traffic coming in between those services, and I didn't pre-populate or pre-build this. It's actually pulled all the request latency, and then I can see where I fit on that 99.5% threshold. You know, was that really the right level to put on a service level indicator? Actually, I think that's not doing too bad. I'm looking pretty good there. And then I can see what my error budget would have been, and then I can finally see where my compliance would have been. And this was a demo cluster. We've only been running load for a couple days, so that's actually why this load stops showing previously there. So that's just a walkthrough of how you can get started building SLOs once they're behind Istio. So at this point, I think I'm going to check on incidents, and I'm going to see if I have any incidents. And look, I actually have budget loss incident. It started, it's now been going for 7 minutes. If I had set up Stackdriver paging or alerting based on that, that would have we've started burning through the budget, the error budget right there. So at this point, what I'm going to do is I'm going to go back and I'm going to see if adding all those raster pods, did that actually help anything at all? I'm going to expand the service bar out, and then I'm going to look at what's been happening with my SLO, and I just want to zoom in really close. And it actually looks like I'm starting to see latency now begin to improve. It reached a bottom, and it looked like it was getting around 98.15%. But now finally, latency is starting to get better. I was burning error budget. I'm hoping that error budget has now stabilized and we're starting to flatten out. You can see I'm now out of compliance. So hopefully these changes will start scaling more and more pods, and at this point we'll start going back into full compliance. And so at this point, I think we've walked through all the major areas.
Well, thank you so much, Tim. So, all right, so let's see, I've got 2.5 minutes. What can I tell you? So just to recap, SRE practices are awesome. Istio is platform technology that helps you get there, so that you don't have to build all the SRE practices into each microservice yourself. Stackdriver automates the creation of service graph, automates the creation of dashboards, automates the graphing of SLOs. Like Tim showed, you just have to supply the target, and it takes it from there. Hopefully, this gives you the best possible visibility into your services, and also gives you the best possible mean time to resolution when problems do occur. I definitely encourage you to see some of the other talks that are out there. And we're in early access for the software that we showed you. It's not generally released yet, so if anybody wants to take a picture of that link, the shortened link, that's the survey to apply for the software to get early access. Yeah, so thank you very, very much for your attendance. Really appreciate everything. And thank you, Tim, for contributing. You would not believe what this guy went through last week. So thank you, everyone, and enjoy the rest of your show.